All right, in this video I'm going to talk about the basics of using Renderman. So in this scene I am just pulling up a Maya file. You don't have to use the same Maya file, but I'm using what's called VDev rig. So it's a look development rig that we have provided for students. And so depending on the class, you should have access to this file, but you can do this in any file. So first things first is I'm going to first check and install my Renderman. So you should have run the executable that came with Renderman. And when you do that, you should get a Renderman tab and then Renderman menu items. If you do not have any of these, you can find and load these in through the Windows tab. So you go to Windows, Settings and Preferences, Plugin Manager. And then through here, you should be able to find the Renderman plugin. So if you come in down here, Renderman for Maya, loaded, auto load, and just make sure that's loaded. If that wasn't loaded, it might take a little bit of time for Renderman to process and include everything. But once you've done that, you should then have a Renderman tab up here and a Renderman menu hotbar section. So when we're using Renderman, we are getting a couple things. First, we're getting a rendering image, right? And that's how we're writing out our 3D scene into a final rendered picture with all the lights and textures and all that stuff. We're also getting some specific elements or pieces that work with Renderman, and that includes lights and materials. So the lights and the materials that Renderman wants to use are very particular. So you can't use the Maya lights and you can't use the Maya materials. Well, to some degree you can, but you're not supposed to use those, and they're not meant to be compatible with Renderman. So if we come over to the Renderman tab, we can find, actually I think we can do create lights. Yeah, so you can see they moved it, they used to have it in the Renderman tab, but if you come over to create, we can create under lights right here, the Renderman lights. And you'll see anything that is Renderman related starts with this prefix PXR, which stands for Pixar. Okay, so we have Renderman lights, and so if we want to see our image, we're going to want to actually use Renderman lights and not the default lights that Maya uses, the Maya standard lights. We also want to work with our materials, which will create either in the hypershade or just by right-clicking and assigning a new material. So for the materials, we can create them and arrange them through the hypershade, and I have a video on how to use Pixar Surface, the main material we're going to use. But we can also, and I go into more detail on how to use the hypershade window in another video that you guys can go back and watch. But I'm just going to assign a new material by right-clicking on my mesh, assign new material. We have this create window that comes up with a lot of material and texture related nodes and files. And so we have a Renderman section now. And our materials are found under BXDF. And so under here, we'll find our shaders for Renderman. My recommendation for you guys is only use Pixar Surface. You could use the constant material or the volume material or Martian or hair or even layer surface, but those are a little bit more edge case. They're very specific. I wouldn't use the diffuse material personally for anything, and then I also wouldn't use the Pixar Disney. So the Pixar Disney is kind of like Pixar. It's like it's a material that's supposed to be able to recreate a lot of different materials, but it's much older and it's kind of outmoded or outdated. So the Pixar Surface is going to be your standard shader that's going to be able to recreate all kinds of physically accurate or physically based materials from glass to metal to skin. So you just use that and assign it to your material. I'm not going to go over into the settings for the materials. I recommend going back and watching my Pixar Surface video if you want to know how to use that. But we definitely need, and let me go, I'm just going to do something so we can look at it. But we definitely need a Renderman or PXR material on our object in order for our renderer to work accurately. Okay. I'm also going to make sure I have a light. So let me go and just delete this as if I had no lights in my scene. So I can create that under here, the Create Lights tab, or you can also do it from right here. These are going to be most of your lights, and these are going to be a dome light. So let's take a look at those really quickly. So I'll right click on this. I'm just going to add a light. So a rectangle light is, let me go ahead and I'm going to do this as 2-panel layout. Okay, so we can see our perspective scene. Here's what we're going to render from. I just did a 2-panel layout and just changed perspective view in my render camera. So I'm going to go ahead and right click on this and choose a rectangle light. And I'm not going to go into the specifics of lights too much. I'm just going to go over the basics to get you started. So with this light, this is we have our standard lights that we're going to be using. These are also called area lights, is your rectangle light and your disk light. And what that does is it takes that whole surface and essentially that whole surface is going to emit light or use that whole surface to emit light in that shape. So with the rectangle one, right, we're getting a rectangle shape in our reflections, and with the disk light, we're going to get circular reflections. So that's really based on what your light source is. I'm going to go ahead and just to show you guys this, don't worry, I'm going to cover it in a second, but I just want to show you what these lights are doing. So I'm going to go ahead and start with a viewport renderer. When you don't have a light in your scene, it's going to use like a default Maya light, right? Which is fine, like it's not hurting anything, and it's going to turn off once you actually add new lights. But that's why it looks like there's a light in there. So I'm going to go ahead and add a Pixar. But as soon as I add an actual light source in my scene, it gets rid of that default light. And now we're working with our light source. So I'm just going to pull this up just to show you guys what I mean with that. So let's go ahead and scale this up. And get this bigger. It's going to go a lot slower when I'm working with the preview renderer. Okay, let's pull that over to the side. Let me go ahead and just pause this for a second and get this into position. Okay, so you can see here I have this light set up, and with this Pixar rect light or rectangle light, it's going to have a rectangular reflection shape. So it's something you got to keep in mind. If I use a disk light, you can see here that that shape of that reflection is circular. So that's the primary difference between those two lights. These lights are physically accurate in the sense that they're going to simulate the size and shape and positioning of a smaller light source pretty accurately. So you can simulate like a lamp that's close by on a desk, or you can simulate a street light that's coming outside that's like 20 feet away from you, and you can get the size and intensity pretty accurately. There's one other type we don't see in here, this distant light. And this is going to be a light source that's going to simulate a really, really, really distant, far away light source like the sun. And so we can see this here. This is distant light. It looks kind of like this right here. And what it does is it doesn't really matter where it's at, position-wise compared to your object. All that matters is the angle it's pointing in. And so it's going to simulate a really, really, really far away light source like the sun. This is mostly used for the sun, or maybe if you want to use it with the moon. So something that has a really, really far distance away, and all it matters is the angle that light source is coming from. And so it's there's going to be really, really harsh shadows, and just like the sun or a really distant light source. And I'll go over it later on, more detail on how to work with lights in Renderman, and like the size and shape and how that affects it. But for the most part, that's the main difference between these lights is the disk and rectangle light, you can position them around, change their size, and they're going to have a lot of like physical properties of like a close or large light source. Like you can get soft shadows, or you can get hard shadows depending on the size. And you can get like a more local light source, whereas the distant light is going to represent something really far away like a sun. So those are kind of where I would use, most of the time I'm going to be using a rectangle light or disk light, and I only use the distant light only if I'm trying to recreate like a sun or the moon. We have another light source here, which is called the dome light. So if we click on this, what it's going to do is a dome light is going to simulate, it's going to take an image and it's going to turn that image into a 360-degree light source. So it's going to take the pixels of that image and turn them into little tiny lights. So let me go ahead and find a map and show you guys what that means. And so here you can see I loaded in an image, and so it's turning that image into a light source. And so, you know, different colors and energy levels of parts of my image, of these pixels, are being read and turned into little light sources. And so dome light is really good for creating a complex, like ambient light interaction between an environment or an object and its fake environment. So you're getting these really interesting reflections and these complex lighting interactions coming from this image. And so it's very common for creating like a fill light or an ambient light that's just kind of adding extra texture and color to the space. But it really depends on the lights or like your environment, and if that light source and that image you're using makes sense for that environment. But let's go ahead and take a step back because I jumped ahead a lot just talking about lights to show you guys these. But so we, just to kind of recap, we need a material, so a Pixar material, and we also need to use a Pixar light to get this working in the first place. So let's go ahead and talk about rendering. So in order to render, we actually have a couple different methods that we can work with. The one I just showed you guys is this viewport renderer right here, which is this little R. Generally speaking, I don't recommend actually using that. It's still a pretty new feature, and I don't think it's very optimized. It's a little buggy, and all the changes you make in your scene aren't going to be immediately shown here. So in order to do a normal render, what you can do is you come over to Renderman, and you have two options. You can do a preview render or an IPR render. Let's go ahead and start with a preview render. So a preview render, what it's going to do is it's going to open this window called Image Tool. And once you click that button, it's going to go ahead and start rendering your image. And what this does is it essentially is going to go through, you can see this progress bar on the bottom left, and it's going to clean up and make multiple passes of your image to get it as clean and accurate as possible, and remove all the different noise artifacts. Because when it starts a render, let's go ahead and click on the render button again, and I'll go ahead and stop it. You'll see when it first starts, it's going to be really, really noisy. And that's just the way that Renderman is creating your renders. Is it starts with a really, really loose guesstimate of your scene and your light interactions, so you can see a quick image of your scene. Each pass it makes over your image, let me go ahead and start another render. You'll see each time it does a pass over, my image gets cleaner and cleaner. So it starts with a really rough approximation, so I can see my image really quickly and get a good sense of what's going on in my scene, even before it's all cleaned up and accurate. And each pass it makes over this is called a sample. In layman's terms, this is kind of what's happening is it's going to be making multiple passes over my render to clean up that original rough guess it makes. So what we do is we get this really, really nice, quick, almost instantaneously rough guess and look at my scene. And then it's going to spend the extra time actually cleaning it up. So whenever I do that preview render, what's happening is it starts the rendering process, and no matter what I'm doing in my Maya file, it's not going to really affect what's going on in here. Let me go and change this really quickly. So it's not actually going to change what's going on in this image, right? As that render is going on, it's going to click it. I can come into my 3D viewport and rotate things, move things around. It's not going to change anything. And that's because once you click on the preview render, it just starts the rendering process separate from Maya, and it's going to go on in the background while you're working. So that's a preview render, or what I often call a single frame render. Okay, we have another type of render kind of compared to that, which is called a IPR render, or it's an iterative render. And it's kind of the same idea as this viewport renderer, where compared to the single frame render or the preview render, it's actually going to make updates to the render or restart the renderer every time you make a change. So if I come over here and I'm going to go to Renderman, go to IPR render. I'm going to select the mesh. Oops, I selected it from the wrong window. Let's do IPR render. Okay, so I come over here and I'm going to go over to my attribute editor, and it doesn't really matter what I'm doing necessarily. I'm just going in and playing around with the material settings. Oh, and my computer's going really slow because I'm screen recording and rendering and working with Maya at the same time. So you'll see as I'm changing my material settings, it's also updating in the IPR render, because until I stop the IPR render, it's going to keep going. Okay, so those are two of the different types of renders that we can work with. And so the single frame render is just going to start the render process and go all the way to the completion, and then the IPR render is going to keep refreshing itself every time I make a change in the material settings or even anything in the scene. Okay. We also have what's called a batch render right here, and I'm not going to go over this right now, but what this is going to do, this is going to send off based on my render settings, which I can find here. Based on this common tab. So if I click on animation and I actually have like multiple frames of animation I'm working with, that's going to take this data and it's going to start a process which is going to take every frame of my animation that I set in my render settings under the common tab, and it's going to export, or it's going to create a render image for every single one of those frames. So it's going to go to start at the first frame, then the second frame, then the third frame, and it's going to take the time to render each of those, just like the when I do the preview render, but for multiple frames. And then eventually this is going to give you image sequence of your whole short or your whole sequence of animation. And so each frame of your animation is going to have a render, and then you can stitch them together later in another program to make it into a video file. But we're not going to talk about that in this video. This is just the basics of how to use Renderman. So this window right here is called Image Tool. Mine's probably looking pretty different than yours is if you're starting from scratch, right? So yours probably looks something more like this. So Image Tool is essentially your render viewer for Renderman. It's going to show you all of your renders and let you manage them. In order to use this, what I like to do first is I like to configure this display appearance of this window a little bit. So first thing first is I go ahead and close this inspector. This inspector is going to tell you information about your render, like how long it took, and a couple of other information about it. But generally speaking, I use it a lot less frequently. And we can always bring it back later if we want it. So I close that to get a little bit more visual real estate. Now I'm going to go to a window, and I'm going to open Catalog. And over here, we have what's called the catalog. And the catalog is going to, every time you click that render button, and you don't close this window, it's going to go ahead and show you, or save each new render you start here as another image. And so especially while you're working and you want to compare tweaks and changes you're making to lighting or materials, it's great to have these images to jump between and compare. So I think this catalog is really useful. When you start a render, so let's go ahead and start if I do a normal render, let's go ahead and click on this. By the way, this button right here is the same thing as clicking on that preview render button. So when you do this, you'll see if a render is currently going in the bottom left-hand corner, you'll have this progress bar. If you ever need to stop it, you have two options. You can press escape on your keyboard, or you can, let's go ahead and start it again, click on this little stop render button. And so that's just going to stop the render for you. And that's going to interrupt it and let you resume. You'll frequently want to do this if you, oh crap, I messed up, I left a light off or something like that, and you just want to quickly restart it. And also, especially if you're working in Maya and things are getting too slow, you might want to stop a renderer because it takes up a lot of resources. If you're using an IPR renderer, you can get the same thing. You can go in here and you can press that button here, or I can click on that, and I think in this case, escape, yep, escape still works. There's another option I have. If I can right click on this and say stop IPR, and that's just going to go ahead and stop the IPR render from happening as well. Let's go ahead and start that IPR render again. So if you ever get into an issue where your colors are looking weird, or you press a button on your keyboard, like I think, let's see if I can press one of them by accident. Oh, yeah, so you can see I lost all color. Sometimes you'll accidentally press a button on your keyboard and you mess something up, right? So I'm losing color. Most likely you're setting a hotkey for your color channels. So if you come in here to View Window and you go down to Color Channels, or Channels, you can make sure you set this. So if your image all of a sudden goes black and white, just make sure you come in here and set that back to RGB for getting all your colors. Another thing you might end up doing, but this is probably less accidental and more intentional, is you can also make adjustments. Make adjustments to your exposure. So that's, you can see it's control brackets, and so you're less likely to actually do this. But sometimes you can change the exposure or gamma adjustment of your image. Probably not something you're going to do very frequently. Oh, let me go back out of that. Go to monitor adjustment, reset adjustment. And you can also change things like your color space. So don't worry about mine. Mine is huge. Yours isn't going to look like this by default. But you can change the color space that your image is being displayed in for the image tool. And so I'm not going to get too far into the weeds on what that means in this case, because I think that's kind of outside the scope of what we're talking about right here. But you can change like how your image, the colors of your image are being adjusted for a certain display output. So most of the time, most likely you're going to be working with, or by default, it should be set to sRGB. And I don't even know if on my computer if I have sRGB because I've messed with my color space settings too much. Yeah, yours should be set to sRGB. So something kind of like that. We have a couple other tools here. So these are just let you play around with the this image tool render viewer a little bit more. So this one right here is the crop tool. What's cool about this is if you don't want to render out your whole image again, like let's say your image is starting to get really expensive, but you just want to kind of see what changes you're making are affecting this area right here. what you can do is you can draw out with this little crop tool, this little frame, just clicking and dragging, and press R on your keyboard. And you'll see what it's going to do is it's going to update only that little area right there. So the render is going to be a lot faster in cleaning up because there's a lot less pixels I have to worry about. But that can be really handy if you want to kind of localize your render and look at a very specific area and want that to go a lot faster. And especially once you start getting more advanced scenes and more advanced textures and materials, this is going to save you a lot of time. And that works for the IPR, but also works for your normal render. So if I start a normal render and then I click R on my keyboard inside here, it's going to go ahead and start that new render, just showing that little area right there for that single frame or preview render. Okay, and if I want to get rid of that, I can just click on that little X and it's going to stop doing the crop tool. If I want to go back to just panning around and clicking and dragging around, I can just click on that little pan tool right there. We also have a tool here that's called the actually wipe tool. Okay, and so what that's going to do is it's going to let you wipe between multiple images and just kind of compare them. So what you first want to do is you want to select a layer, and then you want to click on this button right here, toggle background. So what it's going to do is it's going to set this image as the background. So you can see, even though, let me go ahead and click on that. Even though this image right here doesn't have anything in this area, right? It didn't render out any pixels right there. I can click on this button right here, and that image is always going to show in the background. So if there's no pixels there, it's always going to show that image. Otherwise, the pixels are going to be on top and hide the view. What's cool about this is, let's go to a different render. Let's say this one right here. I can use this wipe tool right here. And what that does is it lets me wipe between the image that I have as my background and the image I'm currently on, the render I'm currently on. So I can kind of compare and contrast my renders this way as well. So it's just another way of viewing and comparing your different render images and seeing what changes you're making and if you think those changes are good changes or not. And I can just get rid of that wipe tool by going back to the pan tool and then selecting my layer and then unchecking that background image. So I deselected that background image. And so when you get rid of that background image, and then whatever you click on is just going to show your image. You'll notice on some of my renders I have a little drop down arrow. And this is going to be for more advanced tutorials or videos later on when I talk about what are called AOVs. AOVs are essentially different pieces of your render that you can separate out, right? Because this image that you see is called the beauty pass. It's going to show you everything. Let me go ahead and show you guys what that means. So in my file, again, this is something that's probably a little bit more advanced for right now, but you can see I've created all these extra little passes that are going to be attached to my render image. And if I come over here and click on this drop-down menu, I can actually see all of those different passes, right? And so these passes have different purposes, right? So some of them are showing different material settings, or material properties. So this is like the diffuse part of my shader. This is the specular reflection part of my shader. So it's just separating those out into separate images. And so again, this is a little bit further advanced than we need to worry about right now, but you can access that with that little drop-down menu to access those. To export your images out of Renderman, what you can do is I think a lot of students screenshot. I think it's serviceable. You might lose a lot of resolution, especially if you are rendering out really, really large images or high quality images. If you take a screenshot, you're only getting the same quality of the screenshot you're taking. Otherwise, you can go to File, Export File, and then you can find your location. Let's say I'm going to put it in my Downloads folder, and I'm going to set it as a JPEG. So depending on how you are exporting your image and what file type you're using, this might turn out totally fine, or it might look really different than what you have in your render image here. So you can see here, this is what I see in my render view, but when I export it as a JPEG, then the image doesn't look correct, right? It looks very inaccurate. So depending on your file type, you might need to do this option called burn-in mapping on save. And so what you can do is you can come over here to Catalog, and then you can go to burn-in mapping on save. What that's going to do is it's going to burn in the color changes that IT is doing into the image when it exports your file. Again, I don't want to get into the weeds about talking about color space transformations and things like that, but what's happening under the hood is when you Renderman is working in a very particular color space, and it looks actually more like, let's see if I can do this really quickly. Right? It looks something like this. This is what the image looks like raw coming out of Renderman, right? And viewed on my monitor or on your monitor. And so you can see that's actually pretty accurate. So this is actually what the image looks like without any color adjustments. But you can see if you go over here and review, we actually have display transforms that are being applied to my image to make it look like it's a certain way, in a certain way, like friendly to certain viewing options. And so with our monitors, we're used to seeing things with a color adjustment of sRGB. And so I can go in here and I'm doing a Lin sRGB. Don't worry, yours probably does not have something that's called that. But yours by default should be, if you go to review image color space, you're going to see an sRGB. And then what it's going to do is we have our display view, and this is what my monitor is working with, sRGB. So it's converting my image to be friendly with sRGB because that's what my monitor likes. And so if I use that burn-in mapping on save, and I click that, I'll go File, Export, File. Let's go ahead and save this as a new one. Save. All right, and now when I open this one up, you can see that looks way closer to what it's supposed to look like. So when you're doing what's called a batch render later on, we talked about that a second ago, about batch render, which is just going to take your whole animation sequence and render out a frame for each one. Then you don't really need to worry about doing this. Generally speaking, you don't need to worry about doing this when you're doing your final renders because you're going to be bringing these into programs that know what the heck they're supposed to be doing anyways. And they don't need to worry about you having to fix these color changes inside of Renderman. But if you're exporting the file just to get feedback on it and share it with other people out of Image Tool, then this is what you want to do. Is you want to go Catalog, Burn-in Mapping on Save, and then Export File. When I go in here to Renderman, I also have been working with something that I haven't talked about so far, but I want to mention it now since it's relevant, is called Always on Top. So you'll see when I click on Maya, Image Tool stays on top. By default, it's not set to that behavior. When I click on Maya, Image Tool disappears, right? So depending on how you like to work, personally I like to always have Renderman kind of on top or hovering. And so if you want to do that, you can go over here to Window, Always on Top. And what that's going to do is it's going to make it so Renderman always has priority and is always going to be on top of your whatever you're working on in your monitor. Last thing I want to show you guys in Image Tool is under Window, Pixel Readout. So by default, you won't have that down there. I'm going to go to here, Pixel Readout. This is another thing I forgot to mention that I really like to have. What it does is it's telling you a lot of different information, right? So it lets you actually view your color channels, or you can see that I only have certain color channels selected, right? Which is, really handy if I'm not sure if I'm actually looking at like my final render image or just like a single color channel. So you see when I have everything selected, it's RGBA and then luminance. And so that's just A on your keyboard to do all of those, just FYI. Here we have underneath our view, our image color space. That's going to be this right here. So I can select those from there too instead of going through the view panel. I also have my XY pixel coordinates. So you can see top left should be 0, 0, right? And that's going to be my 0, 0 pixel. Right, so it's at the 0x and 0y location. And then the bottom right one, in this case, it's a 1K or almost a 1K. I actually don't know what the pixel resolution for this image is, but you know that far right is going to be like my max pixel resolution. So that's just the XY coordinates of your pixels. And each of those pixels are also going to have a red, green, blue, and alpha value to them. And so you can see everything that has, like you can see this background image because this image right here isn't actually going to be in my final render, this dome light, even though we can see it here. You can see when I hover over it, it has actually a 0 alpha to it. So that means it's going to be transparent in the final render when I export it, or when I put it through to another program like Nuke. When I export it from Image Tool, it's still going to show up. If I come over here, you can see when I hover over any of my 3D objects, they have a 1 alpha channel to them. But we also get an R, G, and B values for the pixel color, right? So if I come into like this white area, right, I'm getting actually overexposed. It's going over 1, right? And you can see it kind of reds out, which means that I'm getting a little overexposure. I'm losing information. And then you can see when I get to the dark values, I'm getting really, really, really low pixel values. So this is actually really useful if you, for certain images. Let's go to, let's take a look at a different one. So I have this image right here, and you'll think when you first see it, like, this can't be right. Why is this completely blank? Like, this is just This is a render pass that I created. It's called a z-depth pass, and what it does is it calculates the distance between your camera and 3D objects in your scene. That's going to be used for a lot of different rendering or compositing techniques later on, like depth of field, atmosphere, things like that. So by default, you'll think to yourself, well, that can't be right. This is just white. This is a useless render pass. But you'll see when I hover over this, it's actually changing values in this value right here. So this is telling me what the value of my current image is, right? And you can see it's actually changing. And so that tells me there is something in this image. I just can't see it because these are way greater than 1. They're values that I can't visually see through this image. So anyways, that pixel readout can be a really handy tool, and I think it just has some extra little functionality to it that I like to also include. Something I see a lot of people doing, especially students, is to stop a render, they actually close image tool. That doesn't always work. And in my opinion, I like to always leave image tool while I'm working kind of on. If I want to hide it, I can just minimize it. But just make sure you stop your render by pressing escape or stopping the render itself. That's the only way to actually accurately stop the render. One thing I'll also say is, like I said before, the viewport renderer isn't super accurate all the time. Like if you make a change in your scene, like if I add new geometry or I make a really significant change to a particular material or shader, that change doesn't always update to the viewport renderer. And that actually applies also to the IPR renderer. When I click on IPR and open an image tool, I can actually make changes. Like if I go into poly modeling, and let's say I added a new piece of geometry, but image tool is still running. Let's go ahead and grab that and move it somewhere. Let's pull it forward. Right, and actually, you know what? They might have added this functionality. Oh, it looks like it might have changed. All right, so when I used to work with, or way back when I was teaching this with Renderman, is that the geometry changes and certain changes you make in the 3D scene aren't pushed through automatically to image tool. But it seems like in this case that they have actually added that to have some functionality there. But generally speaking, if you're making some changes in your scene and you feel like they're not being recognized or updated in your renderer, then be aware that that is probably the situation is you're working with IPR, and the best case scenario is just to restart IPR or do a single frame render and see if those changes take place and take effect. So I'm going to go ahead and end this with circling back around to talking a little bit about lighting, because I kind of breezed over that a little bit, but I want you guys, again, I'm going to cover this more in depth in a later time, but I want to at least give you guys the basics of lights. So I'm going to go ahead and create a default light. So I'm going to go ahead and right click and say, let's start with a Pixar rectangle light, and I'm going to actually get rid of this dome light. So I'll just delete that. So I'll go ahead and right click and add a Pixar rectangle light. Let's move it up. I'm going to scale it up. So this arrow is going to say which direction that light source is pointing in, which is what you get with a rectangular disk light. Okay, I'm going to move it over to the side and rotate it, and you move it just like any other 3D object. Anything that is on the side, or is that this side with the arrow is facing, is going to get lit. Everything behind it is not going to be affected by that light source. Let's go ahead and start an IPR. So we'll go over here, click IPR. One thing I didn't mention again, there's a lot of things I'm sure I forgot to mention, is that your render is going to be based on whichever window you have selected. So if I have this window right here clicked on, and I click on IPR, it's going to render from that view right there. But if I want it to be this scene, I have to click on this into this window, and you'll see it gets highlighted, which means that's the active window. I click IPR, and now it's clicking from or viewing from that one. So that IPR is going, and I can come back into this other view as long as IPR is going and make changes and work in this perspective view, and but it's still rendering from my render view. All right, so with your light source, again, don't worry, I'll go into this more in depth later for lighting purposes when you guys actually get serious about lighting. But generally speaking, we have our transforms, and whichever direction or whatever this light source is facing is going to be lit by this light source. And we have some basic settings underneath the attribute editor for this. So we have intensity and exposure. Intensity and exposure are going to be affecting the same thing. They're going to be affecting the brightness of my light source, or how intense the light source is, or how much energy it's putting out. They just do it in a different way. Intensity is going to be like a linear progression of light, and it's going to be kind of pretty gradual and slow. And then exposure is going to be doing more of like an exponential growth. And exposure is actually based on like real world calculations and terminology used for measuring lights. But generally speaking, what I like to do is I like to actually just change the intensity or brightness with exposure and let intensity stay at 1. Or if I want to turn the light source off, let's go ahead and show you guys what I mean. So if I want to go ahead and bring the exposure up, and exposure, like I said, works exponentially, right? So it grows really, really quickly, so you got to be careful. In some cases, you'll have to like dial it in a little bit, just play with very specific values sometimes. So now let me go ahead and I'm going to select that material because that's bothering me. I'm going to select that material. I'm going to change the reflective component to be a little rougher. All right, so I'll come back to that light source. So with that light source, for the exposure, right, I'm going to dial this in very gently to bring this in. You can see that white ball right there is like exploding really quickly. And then exposure, let's say like I get this exposure perfect, like that's what I want, this is the intensity I want, but I need to turn this light off. There's a couple things I could do. I could just hide the light, or I could, this is what I call disabling the light. This is how I work, is I just set the intensity to 0, right? And so that intensity is kind of like a multiplier on top of your exposure. So if it's set to 0, then the brightness is 0. If I set that intensity to 1, then it's going to set it back to that exposure. So I don't have to lose that value I had set for exposure, and I can just turn that on and off with the intensity. That's just how I like to work. Color is going to be a tinting of your light if you're not using temperature. So by default, it's going to be a white light source. So I can set this to like obviously like a red or some other crazy color. And then I can dial that into being like a similar to a real life light source, like a really warm yellow orange kind of light source. If I set that back to white though, let's go ahead and set it back to white and neutral. I'm going to click on this button right here, which is enable temperature. What that's going to do is it's going to change the color based on real world measurements used for determining color. And what I would recommend doing is looking up a temperature color chart. So if you Google this, you can see there's diagrams, and this is how people who actually manufacture artificial lights measure the color of light, is through a number in Kelvin that they call the temperature. And I'm not going to get into specifically why that is, but generally speaking, it's like a theoretical number. If you took what's called a black body metal and you heated it up with a certain temperature of heat, the metal is going to actually change color. And so this is kind of how they're determining it, is like what that color of that metal would be at a certain temperature, and they're assigning that to the color. And it gets a little confusing, and it might seem like, why the heck are we worrying about, like, why do we have that system? It's just kind of like a standard at this point. But generally speaking, if you want to recreate natural lights, they're usually using this color temperature guide. And you can even see there's things like this, from like sunset to like sky color can be measured using these Kelvin settings. So if I want to say like let's go over to, you can even see your candlelight to ultra daylight. I'm going to say if I want it to be like natural or neutral, kind of like a yellow tint, I'm going to set this to like a 4K or 4000. So let's go back into here. I'm going to press T on my keyboard to activate that always on top. And I come in here and I'm going to bring this down to about 4. Oh, that didn't work. Window, always on top. So hopefully that sticks. Nope. Okay. So I think this happens sometimes as a bug. I'm not quite sure what I do that causes it, but even at a certain point when I like leave Maya and come back, sometimes this Windows always on top doesn't work, even with restarting IT. Usually I have to actually restart Renderman or Maya to get that to actually work right again. So I'm just going to move this over to the side for now because I don't want to have to go through that whole process right now. So I'll come over here. We'll come over to that image temperature, and we're going to set that to 4000. And you'll see it's getting that yellow warm hue tint. And that's going to be also multiplying with your light source's color. And that's why you want to leave it kind of at like a white value and keeping that desaturated if you're going to be working with that color temperature. So I'm going to go ahead and disable that color temperature for now. So your light source's brightness is going to be affected by your exposure, but by default, it's also going to be affected by the size of your light source and how far away the light source is from your object. So if I go ahead and scale your light source down, or my light source down, and so we'll make this really tiny. You'll see as I'm scaling it down, it gets actually dimmer, right? And so the size of your light source by default in Renderman is also changing the energy output of it as well. If you don't like that, what you can do is you can come over to, I think it is under Advanced, and you can click on this button called Normalize. And you'll usually have to adjust your values again to get that back to working levels. So let's set that to like, I don't know, 12, 15. Nope, too high. Let's try 13.5. Okay, but you'll see now, if I scale my light source down, it's going to change my shadow qualities, which again, that's more of a light property that I'm not going to go into here, right? Because the bigger light is going to get softer shadows, the smaller light is going to have harder shadows. But generally speaking, the energy output's the same. It's just being emitted at a larger or smaller size. So my energy light, the amount of light that's hitting my surface is generally still the same. The other thing that's going to be affecting our light energy, of course, is going to be distance away from our object. And so there's no way we can, compensate that with normalize or something like that, right? If I move my light source away, further away, but I want it to be brighter, then I'm going to have to probably just increase my exposure. So let's set that back to like, I don't know, 17. I'm going to go ahead and just very briefly talk about this again. This is going to be covered more in depth later on, but generally speaking, your shadow qualities, or the quality of your light, which is, we call a quality of a light would be something like hard or soft, like a soft light or a hard light. And that means the quality of the shadows on the surface. And so a soft light is going to be one where the shadows, one thing I want to, let's go ahead, this is a good time to bring this up. So normally when we do new renders, we have this kind of catalog or library of render images we've created that we can jump between and we can kind of compare them, which is really cool. If you're using IPR though, the problem is whenever I make a change, right, it's not making a new image, I'm just overwriting my image, right? But if you want to not stop IPR and not have to keep redoing a new render, but you want to have multiple versions of your image to compare, you can go into Command and click on Snapshot. What it's going to do is it's going to save my current version of IPR as a render image, a separate render image. And so I can come in here and I can go ahead and make my updates. Let's make this light source a lot bigger, really, really big. And so I can come between my current version and that snapshot version. So let's go ahead and make another snapshot of that one. So snapshot. And then I'm going to go ahead and take this and let's make this really, 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 really tiny. Command, snapshot. So this was actually, let's make this a little bit bigger. And let's go ahead and snapshot this one. Command, snapshot. Oh, actually, that's pretty much the same. So you can see when it's kind of medium size right here. The shadows are pretty, they're pretty okay. When I get really, really small, like this one right here, those shadows get much, like look at the shadow quality right here in the transition areas, right around here and here, right? So when it's medium size, it looks kind of soft. When it's really, really tiny, you see those shadows get super, super hard and super, super sharp. That's called a hard light, and that's where your light source is really, really far away or really, really small relative to your object. And then we have a soft light, and you can see those transitions are super, super soft and very gradual, right? Look at that transition of the shadow, that cast shadow from the body onto the handle, right? So you can see here, this is a medium light, but you can still get a pretty sharp shadow from that cast shadow, but right here it's just super soft and yeah, super soft. And that's because our light source is really large. So the two settings that you'll be messing around with to cause those shadows to be soft or sharp is going to be your size of your light source and the distance of your light source away from your object. And that's the basics of lighting for Pixar Rect and Pixar Disk Light. So those are your standard lights that you're going to be using the majority of the time. Okay, I want to briefly touch on the dome light just very quickly. So we drop in a dome light, and I'm doing this from this perspective view, so it's a little goofy. But with the dome light selected, what you want to do is it's going to take an image file and it's going to wrap it into the light source and turn those pixels of that image to a light source. So you can choose that map by going to color map and choosing it. So generally speaking, this works best with what's called a high dynamic range image, or HDRI. An HDRI is a type of image file that has a lot more values that it can store compared to like a JPEG or a PNG or a TIFF, right? It's going to be like a really large file type that can store a lot of different values. And so usually speaking, or generally speaking, an HDRI is going to have a lot of different value ranges for light sources, like the sun versus like a shadow, right? Those are going to have very, very big or value differences compared to in a HDR, or just like in reality, right? The energy levels of like light coming straight from a light source and light that's bouncing off of like a shadow area is going to be very different. A JPEG or a PNG or most image file types don't have enough capacity to store those vast differences between those energy levels. An HDRI is going to have, it's going to get closer. It's still not going to be able to capture it, but it's going to get closer. And so what you can do is you can actually have pixels in that image that are going to have energy levels that are like hundreds or thousands of times stronger than pixels on another part of the image. Generally speaking, like a JPEG or a PNG, the values are going to be 0 to 255, right? But in HDRI, you can get tens or I think maybe even hundreds. I'm not sure about the specifics of HDRI images, but you can get a much larger value range. And so those pixels can represent much different energy sources. But let me go ahead and find an HDRI. If you don't have one by default, you can go into Renderman. Let's go to the Renderman tab and let me go and bring it up. Renderman, go to Tools and then Preset Browser. And I'm kind of sidestepping quite a bit. But this preset browser is going to have a bunch of presets for materials and other things that you can bring in for Renderman. So if you wanted to start from like a different material preset, like let's say you wanted to make a metal and you're like, I have no idea how to make a metal, you can come in here, select metal and choose it and say right click, import and assign to selected. And then it's going to assign a new Pixar surface material with all those material settings set to what they saved as a preset, right? Which this is really handy. It's really great to kind of look at how they've created things and to learn more about how to work with Pixar Surface or whatever else you're working with in Renderman. But for this purposes, what I'm going to do is I'm going to select this dome light that's in my scene. And I'm going to come over here to environment maps. And so there's some preset environment maps. So you can either bring them in from here or you can download them from online. So you can search for HDRIs if you want a different type of environment. You can right click on or bring them into Renderman and just load them in through this color map location. But I'm just going to use these. I'm going to go over and right click, import and assign to selected. And you'll see it uses that environment image, that HDRI image, to create this dome light that is now being reflected is now emitting light onto my surface, and I can see them as reflections on my surface. Import and assign to selected. So this is a very different one. And so you can see we're getting very drastically different environment lights that are having big impacts on my color. And if I don't want to see it, I can click on this primary visibility option, and that's going to actually hide the environment light from being visible. That's true for the Pixar Rect and Disk Light. I didn't mention that earlier, but if for some reason they're in the camera and you see them as a light source, and like you can see the little shape of the light in the render, you can click on the button that says primary visibility, and that's actually going to hide it. For this light here, you can do the same thing with the Pixar Rect and Disk Light, where you can change the exposure, intensity, and you can also come in here and change saturation. So if I bring the map saturation down to 0, then I'm getting all the different lighting and value interactions from my light source, but it's actually desaturating the map, so I'm not actually getting any color from my environment into my scene, but I'm still getting a complex reflection in here, which can be really handy if you just want more fill or ambient light or more complex lighting source without the colors drastically affecting your materials and textures. Okay, I'm going to conclude this with talking about some render settings. So let me go ahead and start an IPR render. Okay, here we go. Oh, and let me go ahead and make sure that color space is correct. Again, don't worry if yours doesn't look like mine. Mine's crazy. So we have our render going on right here, and let me go ahead and make that a little larger. Ooh. So that's a lot closer up. So anyways, so I wanted to show this because I wanted to talk about very, very basic render settings. So underneath the Common tab is where you're going to find all of the stuff that's not particular or specific to Renderman. So frame range is going to be whenever you do a batch render. Again, we're not going to worry about this for this video or these purposes, but whenever you go into Renderman and click batch render, that's going to go ahead and take the frames in your image. Like in this case, I have a, let's see, a turntable. So the teapot's actually turning around and rotating 360 degrees. So if I wanted to export that whole turntable, then I would just set that to, like from 1 to 360, and then go ahead and click on batch render. And then I'll export or render each of those frames out. If I come over here, we have our camera. And again, that's really more for if you're going to do a batch render. It's going to tell the batch render process which camera to use for rendering all those images out. But if we're just doing a single preview render or an IPR render, while we're working, then we don't really have to worry about that because it's going to render from whatever viewport we have selected and whatever the camera is for that viewport. Down here, presets is going to be our, for image size, is going to be the size of our image. So you can see I'm using a 960 by 540 image, right? So it's not that big. It's kind of a small image. So HD 540, or you can change it up to a different size, or you can insert your own custom pixel size. So let's say I wanted a 1K square. I can do 1024 by 1024. And you can see now it's rendering out at a 1K square. There's also a setting for 1K square I could have used. I'll come over to Renderman. These are where my Renderman specific settings are. And we have one for the normal renders, and we also have settings for our IPR. And there's a lot of different settings here, and I'm not going to go into them all right now. I'm just going to be going over the general settings. So your general quality settings are going to be defined by these values here, which is your min samples, max samples, and pixel variance. Min samples is essentially, we talked about how your image starts off. Let's go ahead and I'll just do this right here. So your image starts off with a really, really rough render, and then it starts cleaning up your image over time, right? And so that samples is going to essentially determine how many times it's going to go over your image and clean it up, okay? And so min samples is telling the renderer, hey, do not stop rendering until you've at least made 32 passes over the image, right? Max samples is going to say, hey, once you reach this many passes and you've done this over the image, even if it's not completely cleaned up and you feel like you can still do better, stop. Like, don't go any further. And so these are really going to control the quality of your final images, right? And it's also going to control how long it takes for your renders to finish, right? So max samples is really, in a lot of ways, a limiter on how long you let your image render for, right? Because especially if I'm doing a single frame render or a batch render, what's going to happen is it's not going to finish the render, or it's not going to stop until it's done as much as it thinks it can, or it hits this max samples value. So it might think it needs to keep going forever and ever, or not literally forever and ever, but let's say my renders are taking like an hour, right? Because it just feels like it needs to keep cleaning up. If I could set this max samples value to a lower value, and then it'll stop it after making a certain number of passes, which is going to save me some time, but at the cost of having a lower quality render. So let's go ahead, and I'm going to set this to different values. So I'm going to go ahead and set this to, I'm going to set this to 8, and I'm going to set this one to 16. Actually, let's do this one. Yeah, let's do 16. Let's see what that does. So I'll come into my viewport, click R, press R on my keyboard to render again. So R is that shortcut to render again. We did that with that crop framing. So you can see this one's a lot rougher, right? Because I stopped it, or I set it so it only goes 16 samples and doesn't go any further. Whereas this one was allowed to go on to 64 samples. And I can come in here and I can do 64, I think it's 256. I think. I might be wrong. Yeah, 256 and the 512. So I'll come in here and click render. So this one's going to be given allowance to spend more time cleaning up, and but it's also going to take longer for my render to finish at the cost of having a nicer render. In this case, it looks like there might be something about my renderer or my rendering that is keeping it or making it stop sooner, right? And so Renderman's going to use its best judgment in a lot of cases. In this case, I think it's because I set this max sample to 8. It was previous 16. So I'm going to go ahead and set this to 64. And so when I click render now, it's going to at least take 64 samples. It's not going to stop too soon. So that's what I actually ran into with this problem right here, is my min samples actually dropped down lower, and Renderman at a certain point decided, I don't need to go any further, it's good enough. And so by setting these min samples higher, it's telling Renderman, no, you need to make more passes to clean it up. And so Renderman goes ahead and goes over more passes. So these two sample values right here are generally speaking going to be the quality control and the time control for your renders, especially when you do your batch renders. Down here we have our IPR samples. You'll notice there's no min samples, and that's because when you do an IPR render, it's just going to keep going forever until you stop IPR, right? Or until it hits the max samples, right? So if I set these max samples really low, so let's say I'm going to set it to 4, right? That's really, really low. And so you can see it stopped really quickly, and let's do actually just like 2. So you can see it just did 2 passes, right? Let's do 1. Does a single pass. 2, 2 passes. 4, it's going to do 4 passes. So you guys can see that. So if I wanted, I mean, there's not really much reason to, but if I want to stop it sooner, I can set these max samples lower for IPR. So these settings for samples are IPR. These settings right here are for my normal renders. I'm doing these as powers of 2. So that's 2, 4, or I guess it starts with 1. 1, 2, 4, 8, 16, 32, 64, 128, 512. Wait, I might have 250, 128, 256, 512, 1024, 2048, etc., etc. These are just numbers that work best with certain computer processes. Is that powers of 2, and so generally speaking, I'm not super savvy on why, but generally speaking, these samples are best to keep at values of 2 just because they calculate better. This value right here is another setting that's going to control quality, and this is what's called pixel variance. And so pixel variance is essentially going to be how fine, if you were like sifting through this with a comb, how fine-toothed that comb would be and how small you're looking, right? And so the smaller this number is, the slower your render is going to be, but the higher quality it's going to be as well. So until you get more experienced, I would just say leave these as they are. The last thing I'm going to talk about is coming down here to these Pixar Path Tracer. So by default, my render is Pixar Path Tracer. There's a lot of different types of renders you can use, like the visualizer, which is going to let you see the wireframe on your model. Or you could use the Unified or VCM, which are very similar to Path Tracer, just using different calculations that are better at certain things. Generally speaking, the Path Tracer is going to be your most artistically friendly one and going to let you cover most cases of what you're going to run into with Renderman. These settings are going to be how much light bounces around in your scene. And so this right here, right, max indirect bounces, is going to be the default value for how many times light can hit a surface, hit another surface, and then keep going. 8 is a decent amount. I think you guys can probably leave it at that or drop it lower. A lower value is going to make your renders go faster at the cost of making it look less accurate, but certain values between, like, let's say 4 and 8, you're not even going to notice much of a difference. But if I set this down to like 1, right, you'll notice I'm actually losing bounce values here. If I go down to 0, it's not going to have any bounce lighting. It's only going to have direct lighting from the light source, right? So let's go ahead and bring that up to 2, 3, and the more bounces I'll let it have, the more light and ambient light that's getting into the shadows is going to be allowed to it. The other values that we're going to worry about here is max specular and diffuse depth. These might not be relevant right here. Let me go ahead and bring up something that might be relevant. So I'm just going to go ahead and assign a glass material to my object. Right, and so we have this glass material that I'm looking through, and let me go ahead and grab the environment light so we can see the environment around it, which will help you guys kind of see that a little bit better. Get a better understanding of what I'm taking a look at. And let's go ahead and move this over to a different viewpoint. Okay, so these values are really going to be affecting how light travels right here. These default ray values are going to be changing how much or how far light is allowed to penetrate surfaces for specular depth, which is going to be like glass materials, and then diffuse depth, which is going to be like skin-like or Pixar surface materials, or subsurface materials, sorry. So if I bring this max specular depth down, what it's going to do is you'll start to notice the inside of the object is actually turning black. And what's happening is this value is essentially telling the renderer how many times light can penetrate a surface before it gets absorbed or stops moving on. So the higher this value means the more surfaces light can penetrate through in a straight line and keep going, right? And so if you're inside of your glass, it could be a surface material, but if you're inside of your glass material is looking really, really dark, this is most likely the setting that you want to take a look at in your render settings, is increasing this max specular depth for your glass to help with that. Diffuse depth is going to be kind of the same thing, but it's going to be associated with material properties that are related to diffuse interactions, and that's going to be something like your Pixar subsurface, the subsurface settings. If you come over here to, if you're using subsurface, which is going to be like a skin-like material, or if you're going to be using something like single scatter, if you feel like the light is actually not calculating correctly with this shader, then you might want to increase this value. But generally speaking, I've never really had to mess with this value that much. The only one I've really had to work with is max specular depth. And generally speaking, this is the most that you're really going to need to get started to working with Renderman and the basic Renderman stuff. Like I said before, if you're confused about all the Pixar surface stuff, and if you haven't watched any videos on this, you'll definitely be very confused about all the settings I was playing around with. But I go much more in depth into how to work with Pixar Surface in another video. So I recommend you guys check out that video to get the lowdown on how all of these different material properties work within Renderman. But that's pretty much all you need to know. You need to work with materials and lights that are created for Renderman in order to get your renders to show up. And yeah, I think that's it.